Hello and welcome back to another video on our topic differentiation. Today we have a very important video as we are going to start by actually doing some examples of differentiation, beginning by finding the derivative, which is a very common question you are going to be asked in the differentiation topic. Now today we're going to be looking at several examples of different kinds of equations and functions with different values of x, but we need to start off with a general rule, a basic rule for differentiation and finding the derivative. So we're going to start off by saying that the basic rule for differentiating a function, let's call this function f of x, and we'll say it's equal to x to some power n, which we'll say that n can be any real number. We talked about this notation in our functions topic, and we say that we are differentiating with respect to x. This is very important that it's with respect to x. So we say that this general rule is that if f of x is of this form x to the power n, then, and this is where we had our derivative, which we defined in our introduction to differentiation video. We said that the derivative, which is f dash x, this is our symbol for the derivative of the function f of x, we say is equal to the formula n x to the power n minus 1. Now let's take a little bit of a look at what we have done here to differentiate to get from f of x to f dashed x. Well, if we take a look at f dashed x, or f of x, sorry, it is x to the power n. So to get to f dashed x, we have brought the power n down to the front and multiplied it by the x. So the n has simply come down to the front and being multiplied by the x. And then we are subtracting 1 from the power n. So it becomes n minus 1. So the two-step process is bring the power down to the front and subtract 1 from the power. And that will give us the derivative. So we'll do a couple examples of finding the derivative. In this case, we are told that given f of x equals x to the power of 4, find f dashed x, which is the derivative. Now I'm going to do this in a bit of a more in-depth process, but usually you should be able to just do one line of working for this. But to help us understand what we are doing to get to this, I'm going to start off by writing that our f of x is equal to x to the power of 4, which is in the form of x to the n. We say that our n in this case is going to be 4. So our derivative, we said was is n x to the n minus 1, which is simply equal to 4x, and then n minus 1 is 4 minus 1, which is 3. So we say our derivative, f dashed x, is equal to 4x cubed. But you don't need to do all this working here. You can just write in your first line of working that f dashed x is equal to 4x cubed by doing this two-step process in your head. So we'll do one more quick example here. This time I'll just do one line of working so we can see we have to differentiate f of x, which equals x to the power of minus 3. Now this time our power is negative. This won't affect anything. It still does the same application. And we're told x is not equal 0, and we're told to differentiate with respect to x. So we're differentiating this x part. So we would say that our derivative, f dashed x, is equal to, bring the power down to the front, minus 3, multiply it by the x, and take away 1 from the power. So minus 3 minus 1 is going to give us negative 4. And this is our derivative. Now, we're not always going to have an equation that is a function. We might be asked, for example, to differentiate some sort of equation that's of the form y equals and then some equation. Well, in this case, the symbol for the derivative is not going to be f dash x. The symbol is just going to change to dy divided by dx, which means the same thing. It's still the derivative, and we still do the exact same process, but we don't, because we've not got a function, we've got an equation, we need a different symbol. And what this means here is differentiate the equation y, and then on the bottom, it means with respect to x. And the final way we're going to look at expressing an equation is if we're not given y equals or f of x. Let's say we're just given some equation x to the n, then we would call the derivative, well, because we've not got y this time, we're just doing dx. And we would always put in brackets what it is we are differentiating. And this is our symbol if we don't have y equals or f of x equals. So here are two more examples, question 3 and question 4, with a little bit of different notation, but we're just doing the exact same thing. So in this case, we are asked to differentiate the equation y equals x to the power. Now in this case, our power is a fraction. Again, nothing changes. It's still the exact same process. And we are differentiating with respect to x. So here, our symbol, as we said earlier, is going to be dy by dx, and we bring the power on down to the front, so it's minus a third x, and then we're subtracting 1 from the power. Now if we look at what that's going to be, well, minus 1 over 3 minus 1 is minus 1 over 3, and we'll rewrite this as 3 over 3, which gives us minus 4 over 3. So we would say that our power in this case is going to be x to the power minus 4 thirds. Let's take a look at this one here. Find the derivative of x to the power of 3 over 2 with respect to x. So here we don't have y equals or f of x equals, so we just write d by dx, so differentiate with respect to x, and we put in brackets what we are differentiating. And this equals, bring the power on down to the front, multiply by x, and this time we see we're doing 3 divided by 2, subtract 1, which is just a half, and this is going to be our derivative. So these are some basic examples of finding the derivative with a little bit of different notation. Now, before we differentiate in our questions, we need to make sure that before we do this, we prepare to differentiate. So it's important that before we do all differentiation, that any brackets in our equation are multiplied out. And also we want to make sure that there are no fractions with an x term in the denominator. So for example, if we had a bracket that said, for example, 3x minus 2, we cannot differentiate this without expanding the brackets. So we want to start off by writing 3x minus 6, and I'll show you how we'll differentiate this in a little bit. But also if we have fractions with an x term in the denominator, such as 1 over x cubed, we need to make this x as the numerator of the fraction before we differentiate. So you might have been taught this before, but if not, if we have 1 divided by x cubed, this is the same as x to the power of negative 3. So x to the negative cubic power. Similarly, if we had, say, 3 over x squared, in this case, this is the same as 3 times 1 over x squared. So we would simply say this is 3x to the minus 2. So anytime we have 1 over x to the power of something, it just becomes x to the negative of that power. So with this preparation in mind, let's do a couple more examples where we have to prepare to differentiate first. So you can see here we are told to differentiate the square root of x with respect to x where x is greater than 0. Now immediately we cannot differentiate this just yet because, well, x doesn't have a power. We want it to be of the form x to the n, as we said at the start. So in this case, we would say that the derivative with respect to x of the square root of x is simply equal to the derivative. Now, how's another way of writing square root x? Well, we say that the square root of a value is the same as doing that value to the power of a half. So we would say that we are doing the derivative of x to the power of a half. And now we have our equation of the form x to the n. And we know here, we just bring the power on down to the front, multiply it by x, and a half take away 1 is going to be negative a half. Now, this would be sufficient to be the answer, but sometimes markers or question papers might ask you to write it with x to a positive power. So how would we rewrite this where x has a positive power? Well, if we remember, the opposite of a negative power is the same as doing 1 divided by x to the positive version. So we would say that this is the same as a half, and it's 1, so it's going to be times 1 over x to the positive version, so x to the positive a half. And we can simplify this a wee bit. Multiply the ones on top just gives us 1. Multiply the bottom gives us 2x to the half. And we can also just rewrite this because we know that x to the half is square root x. So we can simply say that this is equal to 1, 2 times root x. Now this would be sufficient for the answer, but as I said, some markers will like you to give x to a positive power, in which case we go through this process of making x on the bottom of the fraction again. So let's do another one here. Given y equals 1 over x squared, where x does not equal 0, find the derivative dy by dx. Well, in this case, we're going to say that the derivative dy by dx is equal to, well, let's rewrite y first. Let's start off actually by rewriting y because we need to prepare to differentiate first. So y equals 1 over x squared, which as we said is the same as x to the negative power. So now we can work out the derivative dy by dx, bring the power on down to the front, multiply by x, subtract 1 from the power, it's minus 3. And again, I think we'll just tidy our answer up a bit by giving it a positive power. So we're going to have minus 2 times 1 over x to the positive power, which is going to be positive 3. And then we'll just multiply them together to get minus 2 divided by x cubed. So we've looked at equations of the form x to the n, or functions of the form x to the n, but what if we have a coefficient in front of that x? Well, in this case, to differentiate, we say for any constant a, so for any value of a, if our function is now f of x equals a times some function in terms of x, we'll call it g of x, then our derivative now becomes f dashed x equals, the a stays the same, so the coefficient, nothing happens to it, and we multiply it by the derivative of g of x. Now this might sound quite confusing, so we would write a general overall formula. So in other words, if f of x equals a x to the n, where x to the n is our g of x and a is a, then our derivative equation now becomes f dashed x equals a times the derivative of g dashed x, which we said was n x to the n minus 1. So this is the derivative of a function of x to the n with a coefficient a. Gives us this equation here. So again, looking at this, we can see nothing is happening to the a, but it is being multiplied by the derivative of x to the n. Now with differentiation, to get your head around getting practice at it, it's best just to do lots of questions. So we're going to do a few examples here where instead of just having x to the n, we have a coefficient in front of this x. So in our case, a function f is defined by f of x equals 2x cubed. Find f dashed x. Now again, I'll do this the long way first. Well, we know that our function f of x needs to be of the form ax to the n, which we do. In our case, a equals 2 and n equals 3, as you can see. So in our case, f dashed x, we gave the equation a n x to the n minus 1. Substitute in our values, we get 2 times 3 times x to the n minus 1, which is 3 minus 1, which is 2. And then we'll simplify this up a bit because 2 times 3 is simply 6. Now we've got x and then squared. But we can do this without doing all our working. We can just jump straight to this step by taking the 3 down to the front, multiplying it by the a, keeping x the same, and then taking 1 away from the power. So example 2 says differentiate y equals 4x to the power of minus 2 with respect to x. Well, in this case, we are going to find the derivative dy by dx because it's an equation in terms of y. And if you remember, we bring the power on down to the front, multiply it by the a, so 4 times minus 2 is minus 8. Now, if you find this step a little bit tricky to do, it's completely fine to write minus 2 times 4, but I'm just going to do this all in one step by bringing the power down to the front, multiplying it by the a to get minus 8, multiply by x, and then take away 1 from the power. It's going to be minus 2 minus 1, which is minus 3. And again, we've got a negative power here, so we'll just rewrite this as minus 8 over x cubed. Example 3, differentiate 2 over x cubed, where x does not equal 0, with respect to x. So this time, because we have x on the denominator, we have to do a bit of preparation first. Well, let's start by saying that 2 over x cubed is the same as 2 times x to the minus 3. And now we have this of the form ax to the power n. So in this case, the derivative, and we'll write 2 over x cubed, just so they know that's what we're differentiating. And we can also say that this is equal to the derivative of 2x to the minus 3. Well, let's see what we're doing here. Bring the power on down to the front, multiply it by the coefficient, is minus 6x, and then take away 1 from the power, it's minus 4. And we're going to simplify this up a bit to give us a positive power. So we get minus 6 over x to the power of 4. Example 4, given y equals 3 divided by 2 times the square root of x, where x is greater than 0, find the derivative dy by dx. Well, we'll start by rewriting y, so we're doing a bit of preparation to differentiate here. Well, as we can see, this is the same as 3 over 2 multiplied by x to the negative a half, because this is the same as 3 over 2x to the half, which is the same as 3 over 2 times 1 over x to the negative a half, x to the half, which is the same as 3 over 2 times x to the negative half. So this is us preparing to differentiate. Now in this case, we do dy by dx as our derivative. Bring the power on down to the front and multiply it by the coefficient. So we're going to get 3 divided by 2 multiplied by negative 1 over 2, which is minus 3 over 4. Keep x the same, and then take away 1 from the power. Minus 1 over 2 minus 1 is simply minus 3 over 2. So we'll put minus 3 over 2. Now we just need to do a bit of tidying up here. So like we did to get from here to here, but in reverse. But we can see this is going to be minus 3 over 4x, and we've got x to the minus 3 over 2. I'll just do this in an extra step here. Now, if you remember, x to the half is the square, sorry, this shouldn't be a negative, this should actually be a positive. That's my bad, that's the whole point in us doing this. If you remember, x to the half is going to be square root of x. So what is x to the 3 over 2 going to be? Well, it's simply going to be x square rooted, but also cubed. So it's x cubed. The cube should be outside the square root, and we're doing the square root of x cubed. And if you can't remember why this is from Surds at National 5, well, we said that x to the 3 over 2 is the same as x to the half multiplied by 3, which is equal to the square root of x cubed, like so. So this is our derivative. Now, we've just looked at functions and equations that have one term of x. For example, f of x equals x cubed. But what if we have a function of x that looks something like this? Let's say x cubed minus 2x squared plus x. This time we have more than one x in our equation, or power of x. So how would we differentiate with more than one term? Well, we're going to start with a bit of a general formula. We say that if a function, let's say f of x, is equal to more than one function, such as one function g of x plus another function h of x, and remember these are of the form x to the n or a x to the n, then we would say that the derivative, which again we're going to call f dash x, is simply the derivative of each term. So we differentiate the first part, and then we differentiate the second part. So to state this simply, we're just differentiating each term separately. So let's do an example to see what's actually going on here. Well, we have a function f, which is defined for all real values of x, is given by the function f of x equals, and this time we've got multiple things. We've got 3x cubed minus 2x squared plus 5x, and we're asked to find f dashed x. Well, as we said, we just simply differentiate each term separately. So we differentiate this first term, 3x cubed. If you remember, we bring the power down to the front, multiply it by a, put in x, and then take away 1 from the power, and get 3 times 3 is 9, x, 3 minus 1 is 2. The same here, bring the power down to the front, minus 2 times 2 is minus 4. We're going to put in our x, and then we're taking away 1 from the power here. So 2 minus 1 is just 1. We don't need to write x to the 1, we can just write x. And then plus 5x to differentiate 5x. Well, in this case, the power is technically 1. 5 times 1 is just 5. We can put in our x, but we're going to do 1 minus 0, which is 0. And if you remember, anything to the power of 0 is just 1. So this is just going to be plus 5. If we have some value a times x, and we are differentiating this, we simply just get a. So here's one more example. Differentiate y equals, now we've got lots of terms here. We've got 2x to the power 4 minus 4x cubed plus 3x squared plus 6x plus 2. And we're differentiating with respect to x. So we're going to be doing a lot of differentiating here to get the derivative. Well, let's do the first one. We get 8x cubed. Second one, we're going to get minus 4 times 3, which is minus 12x, and we take away 1. Always remember to do that. Squared. Second one's going to give us plus 6x. And we said if we have a value ax and we differentiate it, it just becomes a. So it's just going to be plus 6. Now, if we have a value that doesn't have an x term, which this here is technically 2x to the 0, if we differentiate this, it simply just vanishes. So it would become 0. So this is our derivative here. So if we have a value that doesn't have any x, it just disappears. So before we round off this video, I'm going to be doing several examples where we're going to be doing more differentiating, but this time we're going to be doing a few more complex expressions, ones that you might see come up in exams. So if you want to get some good practice at differentiating, it's probably important that you stick around to look at all these examples that we're about to do. So example 1, y equals 1 over 3x times the square root of x, and we've got to differentiate this with respect to x. Well, first we have x as the denominator, so we need to rewrite this. So we'll say that y is going to be equal to, now I'm actually going to do this in a few steps. We're going to have this to be equal to 1 over 3x times x to the half, so we've got rid of our third first. Now we can multiply x and x to the half, can't we? So this is going to be equal to 1 over 3x, and we just add the powers, so it's 1 plus a half, so we get 3 over 2. And then we make this a positive, a negative a negative power, sorry, by bringing it up to the top. So we get 1 over 3x to the minus 3 over 2. So now that we've done this, we can actually move on to differentiating it. So we've got dy by dx. So what are we doing? Well, we're bringing the power down to the front and multiplying it by the a. Now I'm actually going to write this out all as one step here, so you can see what's going on. And then we've got x, and then we're subtracting 1 from the power. So minus 3 over 2 minus 1 is going to give us, again, we'll make this 2 over 2. So we get minus 5 over 2 as our power. And then here we just multiply these two fractions. We find we get minus 3 over 6, which minus 3 over 6 is the same as negative a half, x to the 5 over 2, minus 5 over 2. And then again, we can rewrite this to make it a positive x power by moving it to the bottom of the fraction. So we simply get that this is equal to negative 1 over 2x to the positive 5 over 2. And again, we can rewrite this as a third by putting minus 1 over 2x, 2 square root x, sorry, all to the power of 5. Example 2, find dy by dx, which just means differentiate when y equals, so this time we do have brackets. We've got x minus 3 times x plus 2. Now, if you remember, when we talked about preparing to differentiate, we said the first thing you must do is multiply out any brackets. So in this case, we say that y is going to be equal to, and we're multiplying at the brackets. So we're going to get x squared, then we're going to get minus 3x, then we're going to get plus 2x, and then we're going to get minus 6, which is simply equal to x squared minus x minus 6. And now we can differentiate this. So we say that dy by dx, bring the power down to the front, subtract 1 from it, minus x is going to give us minus 1. And if you remember, we said that any constants will just disappear. So our derivative of y is going to be 2x subtract 1. Here's our next complex expression. We've got a function f, which is defined for x does not equal 0, is given by f of x equals x divided by 5 plus 1 over x squared. Find f dashed x. Now again, we need to do a bit of preparation here. So we need to start by making sure that x has a negative power by making sure it's not on the denominator of a fraction. Now if you remember, x over 5 is just the same as 1/5 x, because we just multiply the 1 by the x and get x over 5. And this time, 1 over x squared is simply x to the minus 2. And now we can differentiate to find f dashed x. So again, a bit of preparation here. And we'll see this is going to give us minus 2x to the minus 3. And again, we can rewrite this as 1 over 5 minus 2 over x cubed. Example 4, we've got differentiate x to the power of 4 minus 3x squared, all divided by 5x with respect to x, where x does not equal 0. Now here, this looks a bit different because we've got x in the numerator and the denominator. So how do we do this? Well, we simply have to split our fraction up into two fractions. So we would say that x to the power of 4 minus 3x squared all over 5x is going to equal x over 4 over 5x, x to the 4, sorry, minus 3x squared over 5x. And we can now simplify this. So if we simplify this, we divide the top and bottom by x. We find that we're going to get x cubed over 5 minus 3x over 5, which is the same as we said earlier, 1 over 5x cubed minus, and this one is 3 over 5x. And now we can differentiate this. So we would say that d by dx of x to the 4 minus 3x squared divided by 5x is equal to the derivative of this, 1 over 5 x cubed minus 3 over 5x, which is going to give us, bring the power down to the front, we get 3 over 5 x, subtract 1 from the power, we get 2, and then because we have something of the form ax, we just get a on its own, like so. And this is going to be our derivative for our equation up here. Now again, before we move on from this example, I just want to state, if you have an x on the top and the bottom, what you are simply doing is cancelling out any x's. So if you remember, if we have two terms with x on the top and one term of x on the bottom, we can do some cancelling to get rid of this x, which is simply what we have done here. So example number 5, differentiate x cubed plus 3x squared minus 6x, all divided by the square root of x, where x is greater than 0, with respect to x. So again, here we have to be doing a bit of simplification because we have x on the top and the bottom in our preparation. So we're going to start off by saying that x cubed plus 3x squared minus 6x, all divided by the square root of x. Again, we're going to split this up into three fractions this time. We're going to have x cubed divided by square root of x plus 3x squared divided by square root of x. Now actually, instead of square root of x, I'm going to rewrite this. Let me get my rubber. I'm going to rewrite this as x to the power of a half, because that's what it technically is, right? This will come in handy when we cancel out the x's, and we're going to get minus 6x divided by, again, x to the half. And now we can do some cancelling out here. So if you remember, if you divide x over x to the power of 3 of x to the half, you subtract the powers. So we're going to get x to the 3 minus a half. And I'll just write this all out. We get 3x, 2 minus a half, minus 6x, and then we're going to get 1 minus a half. And now we can rewrite this. Let's see, we're going to have x, 3 minus a half is the same as 6 over 2 minus a half, which is 5 over 2. 2 minus a half is going to be 4 over 2 minus a half, which is 3 over 2. So it's plus 3x to the 3 over 2. And then 1 minus a half, well, we know it's just a half. So it's minus 6x to the half. Now we can differentiate this. So a lot of preparation there. That's why this is a complex example. So we would say that d by dx of this fraction here all over the square root of x, we said is the same as the derivative of x to the 5 over 2 plus 3x to the 3 over 2 minus 6x to the half. And when we differentiate this, well, again, we're just doing the derivative of each part. So we're going to get 5 over 2x. Subtracting 1 from this, we should immediately see it's just 2 over 2. So we're going to get 3 over 2 plus, and then 3 times 3 over 2 is 9 over 2 x, and then subtracting 1 from this, it's just a half. And then minus 6 times a half is minus 6 over 2, which we can actually simplify because 6 over 2 is just 3. So it's minus 3x, and then take away 1 from the power, gives us negative a half. And now we can tidy our answer up a bit by saying that this is 5 over 2. In fact, I think I'll write this as one big fraction. In fact, no, I won't, because x is to a power of a fraction. So this is the same as 5 over 2 square root of x cubed, like we said earlier. And this is 9 over 2 square root x. And this time we've got a negative power, so we're going to have minus 3 over the square root of x. This is going to be our final example on differentiating with a complex expression. And this time we're asked to find the derivative of y equals the square root of x times by the stuff in this bracket. Now, if you remember, we need to begin by preparing to differentiating by expanding the brackets. Well, in this case, I'm going to start by making sure we've not got any surds. So I'm going to actually say that this is x to the half times x squared. And then the cube root of x is simply x to the third. So if we expand the brackets, if you remember, when we multiply them, we simply just add the powers. So we're going to get x half plus 2. It's going to be 3 over, oh no, it's not, sorry. It's going to be 5 over 2. And then half times a third is going to be 1 over 6. Sorry, we're adding them. A half plus a third. That's my bad. A half plus a third. It's going to be, well, we need a common denominator, so it is going to be over 6. Multiply this by 3. We have to multiply the top by 3. We're multiplying this by 2. Multiply the top by 2. It's 5 over 6. And now we can differentiate this. So we would say that dy by dx, bring the power down to the front, subtract 1 from the power, bring the power down to the front, and subtract 1 from the power, we're going to get minus 1 over 6. And again, we'll tidy this up by saying that this is 5 over 2. Now it's the square root of x cubed. And then we're going to get plus. Now it's 5, so it's going to go on the top. And we're going to have 6. And then it's the 6th root of x. So we'll write that like such. And that is going to be our final complex expression that we're going to look at differentiating. So a bit of a longer video today, but we've been looking at lots of different examples on how to differentiate. We have learned a lot, so be sure to go back and look at any particular bits that you might struggle with when differentiating. But my best advice when it comes to differentiating is just do as many examples as you can, and you'll get the hang of it by preparing to differentiate, expanding brackets, getting rid of any x's on the bottom of fractions, complex expressions where we're multiplying powers of x, adding them, dividing them. And yeah, so that's going to be it on this video.